Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about a row and column view of system of linear equations. In our last classes, we clearly discussed about the vector algebra basics and the basic intuition about system of linear equations is provided. Please watch those classes and come back here. We are going to use those concepts here. The link for the playlist is provided in the description below. Coming to today's class, let's try to understand the row view and column view of system of linear equations with an example. See, let's take this example. 2x plus 5y is equal to 20. This is a equation, linear equation. 3x plus 6y is equal to 12 is one more linear equations. So the system of linear equations contains two equations and two unknowns. X and y are two unknowns. See, these equations are in a two-dimensional coordinate system. We are having two equations and two unknowns. We need to identify for what value of x and y these two equations are going to be satisfied. That is what we need to identify, for what value of x and y. So before we move on to our next classes, how to solve these equations, first we need to understand row view. What is meant by row view here? See, take in the form of rows, means the first line, first equation has to be taken. So for what values of x and y this equation is going to satisfy? Identify one point, assume that x is equal to 0. If you place x is equal to 0, y is equal to 4, 5 4s 20. So this equation, the points that this equation is going to solve, it is going to form a line. See, 2x plus 5y is equal to 20 is forming a line. The points that on this line are going to satisfy this equation. In that, one of the point is 0, 4 is the point that is going to satisfy this equation. Like that, all the points that satisfies this equation is going to form a line. That is 2x plus 5y is equal to 20 is a line. Similarly, let's take the next equation. We are taking in the form of row. 3x plus 6y is equal to 12. So the point, identify one of the point that satisfies this equation. 0, 2 is the point that satisfies this equation. If you place x is equal to 0, y is equal to 2, 6 2 is 12, 12 is equal to 12. The points that satisfies this equation are going to form a line. In that, one of the point is 0, 2. But what we have to do? We need to identify a point that satisfies both the equations. Means this line is moving like this and this line is moving like this. These two lines are going to meet somewhere. Assume that this is the point where these two lines has met. This point we need to identify. How to identify? We have given some intuition in our previous classes. We are going to do it in our coming classes also. If you solve these equations, we are going to get x is equal to minus 20, y is equal to 12. Means minus 20, 12 is the point that satisfies both the equations. If you visualize this system of linear equations in a row wise, this is how it will be. This is forming a line and this is forming a line. These two lines are going to meet somewhere. That point we need to understand. We need to identify. Now let's understand this system of linear equations in a column view. So the same equations can be written like this. X multiplied by vector 2, 3 plus y multiplied by a vector 5, 6 is equal to, it has to get a vector 20, 12. Means x is a constant, some constant multiplied by, means some scalar multiplied by a vector plus some scalar multiplied by a vector. It has to result in some vector 20, 12. This is exactly same as the algebraic operations of vectors, vector algebra operations. Some scalar multiplied by vector plus some scalar multiplied by vector, it has to result in a vector. So the column view is provided based on vector algebra. But this column view is very, very important. This is the view which we are going to follow in our coming classes. Let's visualize in the column view. See, 2, 3 is a vector. This is the vector. 2, 3 is a vector. Similarly, 5, 6 is a vector. It's in a two-dimensional coordinate system. If you multiply 2, 3 with some scalar, this vector is going to extend. This visualization we already provided in our previous classes. Similarly, if you multiply something with scalar, this vector with some scalar, this vector is going to extend. If you add those two vectors, this is how it looks like. 2, 3 is a vector. When you add it with 5, 6, it goes like this. And this is the vector. This dotted line is the vector which, after adding these two vectors, we are going to get this dotted line. This vector, dotted line vector, we call it as 2012. By multiplying this with some scalar and adding with this the other vector, this is how the visualization will be. These visualizations provided previously, that's why we are not concentrating here. So finally, by adding this, it is going to get a vector. This vector is provided in dotted form. This is 20, 12. This is how we visualize the system of linear equations in a column form. But in most of the times in linear algebra, not most of the times, in always we are going to use this column form. Column view is very, very important in linear algebra. Why? Because that point you need to understand. With the second example, you are going to understand why we go with column view. Let's extend our equations from 2-dimensional to 3-dimensional coordinate system. If you take the equations x plus y plus z is equal to 22, 2x plus 3y minus z is equal to 15, 0x plus 2y plus 5z is equal to 28. These are the system of linear equations provided. Suppose if you want to view this in row view, take the first equation. The points that are going to satisfy this equation are going to form a plane. See here, this blue color plane in the 3-dimensional coordinate system, assume that this is the plane, that's the points that satisfies this first equation are going to form a plane. Similarly, if you take the second equation, this is the plane which is going to be satisfied. Means the points that are going to satisfy this equation is going to form a plane. Similarly, if you take the third equation, this one, the straight one, it is going to form a plane. For better visualization, see here, the first equation, the points that satisfy is going to form a plane. Assume that this is a plane. Similarly, the second equation is going, the points that satisfies the second equation is going to form a plane like this. It's somewhere, it is crossing through the first plane, means this paper should be in the middle like this. Similarly, if you take one more plane, these three planes are going to, see, these are two planes and the third plane will be somewhere, it will be like this. It goes from in the middle from both the planes. See, that's why the row visualization is very, very difficult. Means these three planes are going to meet at a point. That is the point we need to identify. The row visualization is very, very difficult. In 3-dimension, we cannot visualize that point in 3-dimensional coordinate system. Assume that if you are going in n-dimensional coordinate system, means 4, 5, 6, 7, 8, visualization, it's not possible. But if you come with the column view, the understanding is very, very easy. Let's try to understand in the column view. The same system of linear equations can be written in the column view like this. X multiplied by some vector 1, 2, 0 plus y multiplied by some vectors 1, 3 and 2. Similarly, z multiplied by some vectors 1, -1, 5. This system of algebraic operations has to provide the vector 22, 15, 28. How we are going to visualize this in a three-dimensional coordinate system? 1, 2, 0 is a vector, this pink color line is a vector, and 1, 3, 2 is a vector, this green color line is another vector, and 1, -1, 5 is a vector, this blue line is the third vector. What happens if you add these three vectors? This is how it will be. So identifying the point that satisfies these three equations using the column view is good. From our coming classes, this is the equations which we are going to follow. We are going to visualize things in the column view. This is the point you need to understand. Hope you understand what is meant by row view and column view. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.